Assalamualaikum and a very good afternoon. I bid to the evaluators and also to all selected winners for this virtual scientific poster competition. And congratulations to all the winners. So basically, all of the participants already received their tentative or schedule for today's order of presentations. So first, for first presenter, Muhammad Is, I will show the video, the pre-recorded video of Muhammad Is, and this video will be shared approximately for 5 minutes. Then after 5 minutes, evaluators will start asking questions. So we'll come into Q&A session for 5 minutes to Muhammad Is. So 5 minutes for the video, 5 minutes for the Q&A session. Then after that, Muhammad Is will finish his session. So there will be approximately 10 minutes for each presenter. So after 10 minutes, we will have another 5 minutes break in which the participants will break for 5 minutes. But for evaluators, this 5 minutes is allocated for you to fill in the evaluation form that will be sent in the WhatsApp group. Then these steps continue for all presenters. So we have 10 presenters. So each presenters will have 10 minutes, which is 5 minutes for video, 5 minutes for Q&A session, and another 5 minutes is for your break. While for evaluators, 5 minutes to evaluate the video, 5 minutes to ask questions, and 5 minutes to fill in the evaluation forms. So I think that is all for the overall process of today's program. So while Muhammad is presenting, while showing his video, so I will send his poster in the WhatsApp group for the evaluators. So that's all. So any inquiries?
Yep, I'm clear with that. So no question from me.
Evaluators, I already sent the poster for our first presenter. So maybe you can take a look while watching the video that I will be sharing in a moment. So if no any other queries, so I think I can start sharing the video now.
All right, please, Ramzi, whenever you're ready.
All right.
Safety first. That is the common sign we see before we enter lab or any places that require safety precaution. The main purpose is to protect us, the vulnerable creature, from the incoming harm or any incoming incident. Now, in this particular case, I want to talk about the exclusive non-linear absorption property of organic chromophore, to be specific, for the application of optical limiting. Now, I'm able to simplify those jargons with the words like photonics blocker. So it's basically, it blocks photons. So a brief introduction about the nonlinear absorption is, since we are heading towards the Industrial Revolution 4.0, these people want to find the novel material that able to process nonlinear absorption, but not every material able to show this. Single organic chromophore has the ability to show non-linear absorption property and can be further developed into optical limiter, the photonics blocker. So the problem statement would be a lot of demand, and second one, there are less critical appraisal for non-linear absorption or non-linear refraction or any non-linear processes today. A lot of materials available today, they poor in photothermal stability, and it requires complicated preparation virtue. So the significance of this project is we wanted to unearth the knowledge or the various property of non-linear optics itself. That is one. Two is we wanted to serve as future reference, and last but not least, we wanted to develop this organic chromophore into optical limiter. So this research comprises by three main objectives, which are the first we wanted to align the Z-scan setup, which later I will show in the methodology. And the second one, we wanted to determine and to find the value of non-linearities, the non-linear absorption coefficient, the beta, and the third order optical susceptibility of that specific compound. And last but not least, we wanted to find the optical threshold. So this is the methodology. The methodology of this research comprises by a main DPSS laser excitation, 532 nanometer, diode pump solid state, which later the 532 nanometer wavelength to the photodetector. This photodetector will later on receive the signal which I will later show in the result, and the sample, the chromophore, we gonna put it in the automatic linear stage. So we shall proceed with the research flowcharts and results of this research. So this research began with sample preps. So before sample prep, we're gonna optimize the Z-scan or the Z-scan setup, like what type of wavelength we're gonna choose, the focusing lens, alignment, as well as the laser calibration before we operate the Z-scan measurement. And then for your information, overall flowcharts of this research comprises by 4 phases: phase 1, phase 2, phase 3, and phase 4. Phase 1 is sample prep. Second one is the Z-scan measurement. Third one, the UVVs and FTIR characterization. And last but not least is the data analysis for phase 4. I'm not going to show every single graph. So these are the significant graph. It is called the open aperture, what we call as the photonics blocker. It blocks the incoming irradiance from transmitting towards the photodetector. So this is a graphical illustration about what does it mean by photonics blocker. So this is the overall graph of the non-linear parameters we are calculating. MG stands for malachite green. The second one, LGSF, light green, SF yellowish. And last but not least is PBS chromophore. So all of these, they are successfully able to show and provide a great value of non-linear absorption, NLA. All of these non-linear absorption coefficient are in the standard 10 to the power of -4. Optical threshold for each sample have been provided, and among these, malachite green showed the best optical limit because we're able to absorb at the earliest part of the increasing power. The conclusion of this research, all of these stated objective we successfully to achieve, like a Z-scan setup optimization, and then second one, the non-linear parameters we able to show in the constructive table, and last but not least, the optical limiting threshold also is being inserted under the non-linear table. So I believe that's all for today. Thank you for listening, and I'm hoping we're gonna see you later. Thank you.
All right, that is all for the presenter number 1. So maybe all evaluators can start asking questions to Muhammad Is.
Okay, probably I'll begin. First of all, thank you very much for the organizing committee for inviting me as a panel today. All right, so by the way, Muhammad is right. All right, so thank you very much for your presentation. It's very nice work. So my question is very simple. So among the works that you presented as well as the problem statement that you would like to address, can you tell me 2 of the most significant impacts on the project that you propose, which is going to be beneficial to the people in our daily life? What is the 2 biggest impacts? Thank you.
So can I answer it now?
Yeah, sure. Yeah.
So thank you for the question, the examiner. There are, to be frank, that optical limiter is actually a futuristic application. It rather can be used in many sort of devices. But if you ask about the significant, I would say that it serves as photonics safety, because right now we are dealing with a lot of like high power laser or high power energy. So this material, or we wanted to find the best candidate to block the incoming irradiance for like protecting the vulnerable parts like the eyes, to be specific, or sensor. So these my project is like, I want to find what are the material that able to block the incoming high power electromagnetic radiation from transmitting through that passage and able to damage the vital part. So there is one. So second one, it also can be used for military purposes, like it can be tinted towards during the aircraft for the military, and it shall protect the pilot itself from the opposition. I think that's all. Thank you.
Okay, thank you.
I think we proceed with Dr. Kushairi lah. I have to skip with the question for it.
Okay, Assalamualaikum. Can you hear me? Yeah. Okay, good. So thank you so much to Muhammad Is for your presentations, a very good presentation. So I'm from Department of Mathematical Sciences. For most probably they are using a lot of technical formula, yeah, so technical words that I think a little bit lost lah. But it's okay. But the thing that I would like to ask you regarding to your research, I know that there's your research come up from the literature review, right? So you come up with your idea. So what is the novelty that for your research, and then what is the it's not benefit lah, apa yang what we call it bagus your punya research compared to others. Okay, so because all the problem that we propose come out from the literature review. So what is a novelty for your research, and then what is the best thing in your research compared to others? Okay.
Thank you, Doctor, for the question. So the first question relating to the novelty. To be frank, there is no such thing. There's no, in my research, there is no such thing of the new novelty itself, because right now we are actually trying to unearth many materials, and in my research I'm choosing organic material because organic material itself, it has various property. It's like it able to absorb in vast amount of UVV's absorption, and then most of the scientists, physicists, or any researcher, they are using metal which like it's common. So organic compound, they have less critical appraisal has been shown lately. So for me, I'm taking it as a golden opportunity to unearth the value and the uniqueness of the compound itself, so that I'm able to serve as the photonics application. So that is one. So two, for me, since we less to see the value of non-linearities for the organic compound, for my research, it shall serve for future reference. Let's say it able to put down in a constructive manner, constructive table, so that in the future later, let's say the engineer or anyone who wanted to use organic compound to develop the photonics application and photonics devices, they can use our reference to serve for their further development. So I suppose that's all. Thank you.
Okay, thank you. Ramzi, berapa question boleh tanya?
As long as it's within 5 minutes, Doctor. So maybe another one question.
Okay, another one question mungkin Prof C Ho Hang.
No, I don't have any further questions.
Oh, okay,
Thank you.
So last lah okay.
Okay, Assalamualaikum.
Oh, okay.
Can I ask a question?
And
Okay. Maybe simple questions. You said just now, your research can be used to block high radiation material. Is it? Please correct me if I'm wrong, because I'm from bio. Okay, so what is the examples of the high radiation materials that can be harmful to human?
Thank you, Dr. Fatah, for the question. So what are the example? It is a high energies like laser. Most of it is laser because laser is it carries huge energy. So once it enter eyes, it shall it will damage our our organ. Or like for the application of safety purposes like sensors, we wanted to protect those sensors because we want to use that particular device for sensoring. So without a protection, the sensor itself will damage also. Or maybe in bioscience, we are talking about cells, perhaps. So we wanted to protect cells from laser, maybe like high power laser like treatment or anything. So it shall kill the cell, I suppose. So I think that I think that might relate. Thank you.
Okay. Okay, Ramzi.
All right, thank you so much to Muhammad Is and also to all of the evaluators. So Muhammad Is, maybe you can remain if you want to see another participants. Okay, so now we have 5 minutes for the evaluators to fill in the evaluation form. So I already sent the evaluation form in the WhatsApp group. So, but before that, I would like to know whether that evaluation form can be open or not.
Yes, no problem.
Yes, can be open.
No
All right. So I'll start my time 5 minutes from now in order for all of the evaluators to fill in the form. So maybe second presenter, maybe Nabila something. Is Nabila here?
Yeah, I'm here.
All right. So we will wait for 5 minutes. Then it is your time to shine.
Okay, Ramzi.
So we have another 2 more minutes, okay? All right. Okay, time is up. So next presenter, presenter 2 from Nabila. From Nabila, you can ready. So I'll start sharing your video. Wait,
Hi, imagine getting everything that you wish for. That sounds impossible, but not in my research. Over 100 years, people have been using honey and been consuming honey because of its amazing benefit it can do to our body and our health. But we need to remember that only pure honey that contains lactic acid bacteria will do its job well, or else you won't be getting the full benefit of honey as much as the money you have spent for it. Research has shown that every honey that contains lactic acid bacteria will produce ethanol. So, if we can detect the ethanol in the honey, we can know the purity level of the honey. But unfortunately, research has shown that chemical sensors that used to detect the ethanol have shown inconsistency in the detection. This happens due to the surrounding factors, including temperature, pressure, or any other influence. It can also be the concentration of the honey itself. Can you imagine how many people have been consuming the low quality of honey just because of this inconsistency? I know, that sounds bad, right? But it's okay because in my research, I have found a new method to detect ethanol, which I use Raman spectroscopy, which it detects every element fingerprint without affected by temperature, pressure, or any other surrounding factors. I know it sounds so great because not only that, I also implement a multi-layer thin film as an optical filter, so that only light at ethanol wavelength only can pass through, and it will reflect all the unwanted and undesired signals. Isn't that sounds amazing? This is amazing idea because multi-layer thin film have been confirmed to be one of the new technology that brings up so many amazing improvement to the optical applications, and one of them is the sensor technology. So I am here. I am very positive that I can detect every ethanol in the honey. I can also see the future of every honey industry, and honey entrepreneurs are using this technique to detect ethanol in their honey. And now, after this, a lot of people can enjoy the honey with high level of purity. Isn't that sound beautiful? And now, In my research, I have fabricated a multi-layer thin film on FBG, and the result shows a positive and linear result upon the sensitivity. And now I just have to work on the optical properties to get the best ethanol signal. So, what do you think? With the combination of the brilliant multi-layer thin film technology and the Raman spectroscopy specialty with its own fingerprint detection combined together, do you think it's impossible for me to get the ethanol? Not anymore. That's all for me. Thank you.
Okay, thank you for such an amazing pre-recorded video from Nabila. So we are now open for Q&A session from the evaluators. So Nabila, are you ready?
Yeah, I'm ready.
All right. So evaluators can start asking questions.
Okay, as usual, I go first.
Please carry on.
Oh,
To see.
okay. Dr. Sasson, you want to go first? It's fine. You go first then. Sorry.
Okay, all right. Thank you, Dr. C. So to Nabila, thank you very much for your clear video presentation. Right. So you are working on the honey sample. First of all, okay, according to my understanding from your poster, basically you going to detect, or you wish to detect ethanol from the honey sample, right?
Yes, doctor.
And okay, can you explain to me a little bit how does this ethanol concentration levels related to lactic acid bacteria in your honey sample? Did you hear me clearly, Nabila?
Sorry, doctor. How the concentration of ethanol can affect the lactic acid?
No, how this like this. Let me rephrase. How does the concentration of ethanol that you detect by using your fiber Raman, basically related to lactic acid bacteria composition in your honey, right? Because at the end of the day, lactic acid bacteria LAB concentration is very important, right?
Yes.
And how does it relate with the one that you detect is basically ethanol? How does it relate? Does it more ethanol concentration you detect, that means you're going to have more LAB in your honey sample, or how?
Okay, thank you,
According to
doctor.
your understanding.
Thank you, doctor, for your question. But for ethanol, that for the honey that we have been tested, we have proof that the concentration level of the honey is not really affected by the ethanol level, because we have different kind of honey. We have kalulut, we have bee honey, because for kalulut honey, they are not that saturated, but they're not that concentrated, but they still a pure honey.
Alright.
So
your sample is basically from stingless bee or just a normal honey bee?
We do both, doctor.
All right. Okay, I think that's it from me. Thank you very much. I'll pass it to the other.
All right. So I will continue the questions. So thank you very much for the presentations. So my questions is not really related to what you have presented. I'd like to see how's your response on, do you have any idea how you can validate whatever you are doing? How you are able to validate to ensure that whatever you're posing is actually valid at the end? Do you have any ideas how you can validate whatever you propose?
I think the way I can validate it. I try with the current current technique that to detect ethanol, and with my research outcome, so that from there we can know that my research is valid.
Okay.
That's all.
Any other options? Can you propose another options? This is good. This what you propose here is good. So do you have any other options? Maybe another one example?
Maybe we can try to maybe we can give all to industry, and after a month or two we get back from their feedback on our product and on our technique.
Okay. All right. So thank you very much.
Okay, thank you, Doctor.
Mungkin Dr. Patah dulu ke?
Doktor, maybe you tak mute.
Okay, boleh dengar? Okay.
Boleh, Doktor.
Alright. Okay, thanks Nabila for the presentations. One simple questions from me. You use the multi-layer film to detect the levels of ethanol, is it?
Yes, Doctor.
Is it correct?
Yes, Doctor.
Okay. Then what is the efficiency? Is it any data in the percent?
Any data in the percent?
Yeah. Because previously you said that there are another approaches that used to detect the levels of ethanols because it's indicate the purity of the madu, right? Nabila, you are mute. I cannot hear you.
Sorry, Doctor, because in this technique, Raman spectroscopy, it can only detect the ethanol itself, only the fingerprint of ethanol. We have used combine the methanol and ethanol because this signal, this fingerprint of methanol and ethanol are very close. But when we use a Raman spectroscopy, we can detect only ethanol, so we can see the difference. So they not get mixed together because the industry have problems in they confuse with ethanol and methanol because their signal and their fingerprint is quite similar.
Okay, thanks.
Okay, Nabila. So for my turn lah, saya rasa for me just a simple questions because a lot of questions have been asked by other evaluators. So basically, I want to ask the validations as a Prof. C asked you already. So my simple question is, you have a future plan. So basically, what's actually your future plan that you already planned after this? Because you already mentioned your multi-layer impressive that you have mentioned before this is a good result. So I think you need to have, or you already have your next planning for your future research. What is your next planning for your research product? That's my question.
Thank you, Doctor. So for now, we have fabricated a multi-layer for a couple of fiber, but we need to do more on another fiber because we need the repeatability of the result is high. So we don't want to if we fabricate another fiber, the result is not the same. So even though we have get the result, we still are going to fabricate the multi-layer, this filter on quite numbers of fibers, so that we can prove that we are having a high repeatability of optical filter.
So it means that after this you will use another fiber to.
Yes, another fiber, and because this process is this deposition process is very long process, so we need to make sure that we are doing the result is same. If we are want to fabricate more, so we can only have one fiber, right? For let's say that many industry want to commercialize it, we need the repeatable level of the sensor itself is high.
Oh, okay. Thank you.
All right.
Okay, all right. I think that's it for now. So I would like to express my gratitude to our second presenter. Now, all evaluators are given 5 minutes to fill in the evaluation form for Nabila. And I hope that our third presenter can start ready. So the evaluation form has already been given in the WhatsApp group of evaluators. So while waiting for the evaluation, so I'll share with you our third presenter posters. Okay, so I would like to, I was wondering whether our third presenter has already in or not.
Yes, I am.
Okay, it's Miss Pavitra, right?
Yes.
Right. So there'll be another 3 minutes for you to get ready, okay?
Okay.
Okay, all right. Time is up. So I'll start sharing the video from our presenter 3.
A very good day to everyone. I am Pavitra Nandagopal, currently doing PhD at Department of Bioscience. Today, I would like to share my research work entitled Cyanobacteria. You must be wondering what is Cyanobacteria. It's alright. I will go through one by one through my poster. Cyanobacteria are defined as blue-green algae that have been studied greatly for its structure and photosynthesis mechanism. In this study, we are only focusing on in-cis genetic modification, which involves in transformation and homologous recombination. For an example, insertion, deletion, or replacement mutation. In general, E. coli are used to produce high-value biological products in transgenic expression. And so far, there is no compatible expression plasmid is available for transgene expression in cyanobacteria. And that is why we have come up with this study. There are two objectives in my study. First, to design and assemble an expression vector that has neutral site and gateway expression cassette for cyanobacteria. Secondly, to determine the compatibility of the plasmid for transgene expression in cyanobacteria from the positive E. coli transformants. You can see the diagram in methods. First, we design parts and expression vector and then cut the parts including antibiotic resistant, expression cassette, and neutral site using restriction enzymes. And then we assemble the expression vector P-Cyno03 using seamless cloning kit. And then we transform it into E. coli. I would like to highlight a concept over here where involving scissors and glue technique, where you just cut and also paste. In results, we have obtained P-Cyno03 with 6 kbp nucleotides. The yellow part represents neutral site, the green part represents gateway expression cassette, whereas the red part represents antibiotic resistant. Each part in this plasmid has its own role. Gateway expression cassette was proposed to assemble multiple DNA fragments to manipulate the genes in microbial hosts, whereas neutral site is important for stable gene expression and longer survival of gene. Hence, P-Cyno03 can be transformed into E. coli to obtain multiple copies of plasmid before transforming into cyanobacteria. In conclusion, P-Cyno03, which consisted neutral site, antibiotic resistant, and also expression cassette, can be used as a modular plasmid devices for gene expression in cyanobacteria. That's all from me. Thank you so much for listening this poster presentation.
All right, thank you so much, Pavitra, our third presenter. So the Q&A session has already opened, so all evaluators can start asking questions.
All right, if there's no one to start, let me start first, okay? Hi, Sarah, how are you?
Yeah, I'm good.
All right, that was a good and very composed presentation. So I just have a few questions. I think. All right. Example, basically, what you've been doing is on what they call it as cyanobacteria, right? Which is what you define as blue and green algae, right?
Yeah, okay.
As according to your understanding, to the best of your knowledge, to what extent that your work is basically novel? I mean, how does it differ to the other previous work that might as well working on maybe any types of algae as well? How does it differ from previous work that work on algae as well? That is my question. Thank you.
Actually, we are not working directly on the algae. This is more on developing an expression vector specific for cyanobacteria. All right, so now I have assembled an expression vector and I have transformed it into E. coli to obtain high copy number. And then this is just a part of my project. And then what I will do is I will clone flavonoids and then transform it into cyanobacteria by using bioreactors. So for now, this is all about my project. So
Okay. All right, so I move on to the next question. So thank you very much for the presentations. All right, so my question will be, you are going to design an example and expression vector. How actually you are going to characterize whatever you example and ensure that the vector is the one that you would like to achieve?
I'm sorry.
You're trying to design an example expression vector, right?
Uh-huh.
So technically, I'm asking, I'm not a really bacterial person, but I'm just wondering how you actually want to justify the vector that you design is the one that you are aiming for. Is there a way to justify for that?
Yes, there is. You just have to send the samples for sequencing, nucleotide sequencing. Yeah, and then use blast nucleotide just to check the the nucleotides presence.
So is this under your scope?
Yes, it is.
Okay.
It's just a validation method that's later on. Yeah.
Okay. So if when you perform validation, if it fails, it doesn't really you do the sequencing, but it doesn't show whatever you want to design, then what is your solution for that? Are you going to use whatever you design, or you are going to keep trying to design until the end of your project, you're still trying, or you have a plan B for that?
For now, there's no plan B.
Okay. No problems. Thank you. Thank you very much.
Okay, can I go next? Okay, Pavitra, right? Thanks for the presentations. So let me get you clear that you are going to develop expression vector in cyanobacteria, is it?
Yep.
So can you give a reasons why you prefer cyanobacteria instead of E. coli? Because E. coli is already stable. You know, it's well-known vectors. Why you prefer cyanobacteria? Okay.
Because so far people are not using cyanobacteria. So it's
Why
very
you get yourself into the difficulties due to the cyanobacteria? Why don't use the E. coli? E. coli is an established systems. So it's easier and convenience for everyone. Okay. Your opinion, maybe?
I will still try for cyanobacteria. Let's come up with something new.
Maybe you can highlight on the novelty. Okay, my second question is regarding to the antibiotic resistance that you develop for your vectors. Can you give a reason why you use that specific antibiotic? Why not ampicillins or penicillins?
Okay, so initially we have ordered the parts that I have used for, like, example, there are different parts like antibiotic, nucleoside, blah, blah, blah. Okay, the genes, we have ordered them from US. So they have like from US, it was developed from another person in US, which is Teton something, and then we bought it, and then we have to like transform it into E. coli, and they have given like a, how to say, a verified wait, let me put in words. So they have published a paper. So from that paper, we knew that that part is actually only for SPSN, which is streptomycin and streptomycin, according to the paper.
Okay, thanks.
Masih lagi ke, Hamzi? Kena
Okay,
enough. Boleh ke?
Last question.
Okay, last question. Okay. So for me, it's a very simple one lah. Regarding to your research significance, you have mentioned that can be used for the productions of biological products, right? So is it any the specific application that can be applied for your research? Specific application.
Maybe we can do this biofuel or bioethanol. We can produce that if I able to insert the flavonol and also clone them into cyanobacteria.
So is it possible lah?
Yes, it is possible.
Okay. Okay, itu saja Ramzi. That's all. Thank you, Fabrita.
All right, thank you.
All right. All right. Thank you so much to our third presenter and to all evaluators. So I would like to express my highest gratitude for such an amazing presentation and question and answer session. So now all evaluators are given 5 minutes to fill in the evaluation form for Pavitra. So while waiting, our fourth presenter, which is Reza, are you here?
Yes, I'm here, Ramzi. Can you
All
hear
right. Okay, you can start ready for your session, right?
me? Can you hear me clearly or not?
Yes, I can hear you, but it's quite echoing at the moment. Can you test again?
Test.
Okay, clear.
All right.
All right, seems like all evaluators are ready and already done with the evaluation. So maybe we can just start with our fourth presenter. So let me share our fourth presenter's video.
Hi everyone, my name is Muhammad Reza bin Muhammad Razi, a PhD student from the Department of Bioscience. Available conventional therapy for breast cancer management often resulted in systemic and neurological toxicity and most critically cancer recurrence. One of the existing chemotherapeutic drugs, paclitaxel, is highly hydrophobic. Due to this, rapid paclitaxel clearance has been observed, thus a high dosage was required to maintain its efficacy. As a result, there have been issues reported as paclitaxel cause acute and severe adverse reactions such as nausea, vomiting, and
Sorry, can you guys see the screen actually?
Ramzi, it's actually stuck. I think it's because of your
Wait,
connection.
share it again. Wait, I think this video is quite HD, that's why it's quite stucking. Wait, wait, yeah. Okay, let me share again.
Everyone, my name is Muhammad Reza bin Muhammad Razi, a PhD student from the Department of Bioscience. Available conventional therapy for breast cancer management often resulted in systemic and neurological toxicity and most critically cancer recurrence. One of the existing chemotherapeutic drugs, paclitaxel, is highly hydrophobic. Due to this, rapid paclitaxel clearance has been observed, thus a high dosage was required to maintain its efficacy. As a result, there have been issues reported as paclitaxel caused acute and severe adverse reaction such as nausea, vomiting, and hair loss. Hence, alternative therapy such as the photothermal therapy has been developed and introduced to combat such issues in breast cancer management. Therefore, our study entitled Paclitaxel with Local Photothermal Therapy for Improved EMT6 Anti-Cancer Strategy aims to provide an alternative therapy for the breast cancer management. The objectives of this study are to study the effects of the paclitaxel with hyperthermia in EMT6 breast tumor model and to evaluate the median survival of the mice post-treatment. Initially, EMT6 breast cancer cells were cultured in and inoculated subcutaneously at the right flank of the biopsy mice. After 7 days post-inoculation, mice were treated with the combination of paclitaxel and hyperthermia, paclitaxel only, and untreated mice as the control group. The hyperthermia procedure was set for 30 minutes at 43 degrees Celsius, and the procedure was performed for 3 consecutive days. The tumor progression was monitored using the digital caliper every alternate days for 50 days. Mice that achieved the tumor size of 150 millimeters square were sacrificed according to the Animal Ethics Committee guideline. The statistical data was generated using the GraphPad Prism for all animal experimentation. The data from this study revealed that there is a delay in the tumor growth in combined treated mice, with 2 of them were breast cancer free. Meanwhile, untreated and the paclitaxel treated only mice experienced faster tumor growth as compared to the combined treatment. In the survival median analysis, mental cock test was performed after 50 days post-inoculation. The data showed that the median survival of the combined treated mice was increased to 27.5 days, while the PTX and the untreated mice were at 22 and 17 days respectively. Overall, this study proved that the combined therapy has successfully delayed the tumor growth while prolonging the median survival of the tumor-bearing mice. Therefore, it is hoped that the application of the chemophototherapy combination strategy can be further understood for effective breast cancer management in the future clinical settings. That's all from me. Thank you.
All right. Thanks a lot for the presentation, and I would like to apologize for the hiccups that just happening just now. So now all evaluators can start asking questions to our presenter.
Hello. Hi.
Hello,
Saya
hi.
ingat tak ada orang nak mula, so saya mula dulu. Sorry. Okay, very quick one. So thank you very much for your presentation. Okay, I just wondering this PTX that you would like to introduce. What is the therapeutic drug monitoring level that you can consume into the human body? Do you have any idea on that?
Yes, doctor. So, can I, if I understand what your question is, do you mean the dosage of the drug that has been administered into the patient in the clinical setting?
Yes, in terms of clinical trial effect, what is the therapeutic range that is really working? How
I
much is
see.
the working range? Yeah.
So the standard therapeutic range that has been applied in the clinical setting are around 1.75 milligram per liter. As for the breast cancer, since PTX has been used for the wide range of cancer therapeutics, and for me, my specific part is on the breast cancer therapy. So for the node positive breast cancer, which is on the stage 1 and stage 2, the range is between 1.75 milligram per liter for the in the patient for the clinical settings.
Okay. So you are going to apply following this range, or you are now not considering the range when you are doing your study, when you react with
I
the
have
yeah.
Yes, understood. Thank you, doctor. So I have to cater between the literature and also the standard administration of paclitaxel. Therefore, we've been referring to different literature review, and my study is below the range that has been used in the clinical setting, which is at 1.5 milligram per liter right now.
All right. Okay. Thank you very much.
You're welcome, doctor.
Do the evaluators have any other questions?
So the question that I'm about to ask is basically quite similar to the one that being asked by PM Dr. C Hong Heng. So I just keep with this one. Thank you.
How about Dr. Kushairi and Dr. Fatah?
Okay, Reza,
Yes, doctor.
thank you for the presentations. Do you try these combinations of PTTX and the phototherapy
Yes.
to another types of cancer?
Eventually we are not testing it on another type of cancer since following our literature review, this is the only one type of cancer has not been tested for this kind of therapy. I'm not saying that this kind of therapy has been introduced in the another articles or another scientific study, but our novelty on this part is focusing on the EMT6 since EMT6 is the aggressive types of the breast cancer. And I'm well aware that cancer can relapse or even can happen on the tumor recurrence itself. So we basically want to try on the 41 breast cancer cell line, which is the metastasized breast cancer, but it is on our planning right now, not on the clinic testing.
So you already tested the combinations on mice, eh?
Yes. We also have the data on the in vitro analysis, but for this competition, I purposely presented on the data for the mice study.
So between the in vitro and in vivo studies, is it the results compatible? I mean, is it complementary, support each other?
Yes, as the results are fortunately significant right now. So we hope we really I think we are really lucky to get the significant result both in vitro and also the in vivo testing.
Okay, that's all. Thanks.
Okay, thank you so much for your presentation. Reza, betul? Okay, I think the simple one. So this one actually you develop the potential alternative therapy for future breast cancer kan. So,
Yes.
is it there is the kata apa that can be applied to all the breast cancer human. I mean orang yang kena affected tu your alternative therapy ni apply to all ke, or they have a certain age ke?
Oh, I see. Okay, thank you, doctor. So for my type of proposed treatment, we focus on only 2 stage of breast cancer, since breast cancer has about 4 stages, right? So for my part, it is only on the early diagnosis, which is on the stage 1 and the stage 2 of breast cancer.
Thank you. So that means tak kisahlah, it doesn't matter how age ke, young ke. So but you just focus on
Yes,
that.
yes. It apply to all range. And as for now, breast cancer are most popular for females. So right now you're only focusing on the females.
Okay, thank you.
You're welcome, doctor.
Are there any other questions from evaluators?
No.
So if there's no question from the evaluators, so I think that's it for our fourth presenter. So now all the evaluators are given 5 minutes to fill in the evaluation form for our fourth presenter. So for our fifth presenter, which is Haris, are you here?
Yes, I'm here, Ramzi.
All right, thank you. So you have 5 minutes to get ready. Okay, all right. Since we don't want to wait any much longer, and since all the evaluators already done with the evaluation, so we can just start with our fifth presenter. So I'll stop sharing first. So I'll start sharing the video of our fifth presenter.
Greetings, I'm Haris, a PhD student in Department of Biosciences, Faculty of Science. I am currently in my 5th semester and being supervised by Associate Professor Dr. Nik Ahmad Nizam Nik Malik and Dr. Karina Dajamon. What is the first thing that crosses your mind when I say silver? Silverware? Silver medal? No, definitely not. I am pointing to silver nanoparticles. We all know that silver nanoparticle exists in a very small size which cannot be seen by our eyes but only through electronic microscope such as transmission electronic microscope. Silver in their various forms are capable to exhibit antibacterial properties independently or when combined with other compatible materials, which in this case are synthesized zeolite A. Generally, zeolite is a mineral with porous structure which enable the incorporation of silver nanoparticles within its structure. Analogically speaking, imagine a rack with lots of holes. It can only accommodate particles which fit or smaller than the hole itself. Another interesting fact in the study is that silver nanoparticle was made using our local herb called misai kucing. How so? Well, instead of using dangerous chemicals such as sodium borohydride or physical methods such as laser or heating, silver nanoparticle is made by mixing silver nitrate solution with an optimized volume of the leaf extract. And therefore, a chemical process called reduction occurred, converting silver ions to silver particles. Our research upholds the Sustainable Development Goals SDG, which is to reduce the adverse environmental effect by substituting chemical physical processes with a greener method using locally available misai kucing leaves. This will give the impression that the green chemistry is definitely possible and a thing of a future. Silver is forever an enemy to bacteria. Its antibacterial property can be further modified when incorporated into porous zeolite A structure. The green concept of synthesis is easy enough to comprehend, in which the commercially available kaolinite and misai kucing leaves are prepared to produce zeolite A and silver nanoparticle respectively. The combination of both materials produce silver nanoparticle incorporated zeolite A, which function as an antibacterial and antibiofilm material. As mentioned in the objectives, we expect that the synthesized material is able to exhibit antibacterial property and biofilm inhibition action. And guess what? Our hypothesis is true. Firstly, silver nanoparticle incorporated zeolite A was successfully synthesized and characterized. The silver nanoparticle is shown to be incorporated inside the zeolite A framework. Secondly, the synthesized material exhibit antibacterial activity using this diffusion method against gram-positive and gram-negative bacteria. Lastly, the synthesized material also shows significant biofilm inhibiting property towards Staphylococcus aureus. One must be wondering, how does these tiny particles kill the bacteria? There are many possible mechanisms, and one of them involves the disruption of the channel protein of the bacterial membrane by silver nanoparticles. This channel is like a door allowing in or out of a particular compound. If this door is broken or destroyed, the bacteria is unable to work as efficient as before, which eventually causes it to die. On the other hand, in the aspect of antibiofilm formation, silver nanoparticle incorporated zeolite A eventually release silver ions, which are positively charged and are attracted to the negatively charged extracellular polysaccharide of the biofilm. After its ionic attachment, the silver ions work its miracle to kill the bacteria sheltering inside the biofilm. In the conclusion, silver nanoparticle incorporated zeolite A was successfully synthesized and characterized, and additionally, the antibacterial and biofilm inhibition activity showed that Staphylococcus aureus is the most susceptible strain. Thank you.
All right, thank you so much for our fifth presenter. So now we are open to Q&A session from the evaluators.
Maybe I'll start first. Thank you very much, Ramzi. And thank you very much, Haris. Basically, I enjoy your presentation so much. I just have a quick question for you. Basically, you mentioned that in your poster, basically chemical reduction method you are using, and you mentioned in your video just now it is greener than laser method, right? So I'm a laser guy. I have to ask this question. Based on your understanding, how do you think that your method is greener than laser ablation method, right? That is my first question. My second question is, why did you choose this misai kucing, and how does it better as compared to the other reducing agent, for example, T3 leaf ke, or daun kucai ke, and what other local herbs that we can find? I think, that's my only question. Thank you.
Okay, thank you, Dr. Safwan, for the question. I hope you guys can hear me. Okay, all right. So, basically, answering to your to both of your question, well, I would like to basically emphasize the SDG, the Sustainable Development Goal, is basically what we're going to achieve now, which we're going towards a path of a greener application or a greener production and so on. Okay, answering to your first question, why do I think that green is better than laser or physical method? Basically, the most comparable thing that I would like to highlight is the use of energy in this case, which means laser or heating use a lot of energy compared to physical mixing of producing this silver nanoparticles using greener methods such as the misai kucing leaf, because we all know whatever mechanical things, electrical things usually require electrical energy, which is produce heat and so on. So by converting or shifting towards a greener method such as using the local herbs, so we can reduce this use of energy and production of heating that is some kind of waste of energy wastage. Okay. Secondly, why do I use misai kucing rather than other kind of herbs? So there are a lot of herbs in Malaysia. We can talk a lot of herbs in Peninsula, even in Southeast Asia itself. Why misai kucing? Because misai kucing itself is a very special herb that mostly and commonly found in the Peninsula of Malaysia only. So even misai kucing itself has lots of families and subspecies. So before we try to use the misai kucing leaf itself, we need to identify whether this misai kucing leaf exactly works to reduce silver nanoparticle or not. That's all.
Okay, Haris. Dengar tak saya?
Dengar, Doktor.
Okay. Thank you so much for your presentations. Okay. So actually related to the second questions of Dr. Safwan, okay, you choose a misai kucing, right? So is it any misai kucing apa sebagai agent, right? Agent. So beside the misai kucing, any herbs that can be replaced? The same result ke, the same property ke?
Okay, in the concept of synthesizing nanoparticles using a greener approach, such as plant, there are a lot of other herbs actually. That's why we can do misai kucing, because we have lots of literature review that we can refer to, such as if we go for cooking, we use a lot of herbs such as rosemary, thyme, basil, and you know what? All those herbs has been perfected and used to actually reduce silver nitrate to silver nanoparticle itself. So because we don't have that herbs in Malaysia locally, we need to import them. So why don't we just establish a database of these local herbs for us? For starter, we have misai kucing, we also have daun kesum, we also have the daun soap. But most importantly, the compound that specifically helps to reduce is the phytochemical compound inside the plant itself, not basically the whole plant. We can study everything. It can be another type of study if we just want to study the plant reducing property only. I hope it answers.
Thank you.
Okay, Dr. C, you want to go first?
It's okay. I'll wait for the last one then. Okay, you go
Okay.
first then.
So Haris, what usually, what is the types of bacteria or the species of bacteria that usually available in the wound?
In the forest, you mean?
In the wound, luka.
Wound, oh, wound. Okay. Okay, so basically the bacteria available, they are present not actually on the wound, but on the skin. On the skin itself, there are also already a bacteria. But when they are wounded skin, these bacteria are enabled to be penetrated inside the skin, which means they can penetrate not from the first layer, but towards the second or third layer of the skin. So these bacteria actually that are already available on the skin can induce a severity of the wound. So that the bacteria that is very common is actually E. coli, Staphylococcus aureus, and other types of strain as well. Because in our lab, we have representative of gram-negative and also gram-positive bacteria. So these bacteria are inclusive, and they are also a stable type of bacteria which obtained from the ATCC, the American type cell culture.
Okay. Have you tested your silver nanoparticle on the wound?
On the wound, actually, I tested it out on in vitro scale only, not in vivo. But that's another part of my study which I have completed, but I did not include in this poster.
So what is the result?
Basically, the result is good, which means that the silver nanoparticle incorporated into the zeolite A framework is not cytotoxic or not cytotoxic enough to induce cytotoxicity to the cell, which means in this case I use human skin fibroblast cell. It's just the representative of our skin.
Okay, thanks.
I just have one very quick questions. What's the function of zeolite A in theory?
What's the function of zeolite A?
In your research?
In theory,
Yes.
in my research, okay.
Yes. What you want to achieve with the use of the zeolite A?
Okay, so basically when I just present this poster, I cannot include everything in my study because I don't think I will fit everything into one poster. I think I need up to 10 posters to basically explain everything. So in easier terms, zeolite itself is like a basket. In my research, it's like a basket that we put something that is good or that is useful. So when it's time to use this compound or agent or something that we put inside the basket, so we can take it out whenever we want. So scientifically speaking, so zeolite itself is a porous framework, just like I said in my poster. So it can fit. It acts as a carrier that can fit something inside itself. So basically, it can carry something or compound or material, anything that is related and suitable so that it can be used. So in this concept, when we put the silver nanoparticle incorporated into the zeolite towards or against the bacteria, so this carrier or basket help to release the content inside of the zeolite to the bacteria, so it can attack the bacteria on the spot.
Okay, I just want to comment a bit, You have to know that in drug developments right now, there's a lots of latest technology on microencapsulations. There's no something using these kind of zeolite things anymore. So just wondering, is it feasible to keep going to do zeolite? Because microencapsulation, you can do different kinds of things that just encapsulate your silver nanoparticles, and
yes,
you can put it into the ointment, you can put into different kinds of the drug applies features. All right, thank you very much.
Thank you, Doctor.
Before we're taking a break for 10 minutes, can you guys open your camera for a while for a photo session? for those who still here, can you guys open your camera for a photo session before we having a break for 10 minutes? So I saw Nabila still here, Reza, Wan Faiza, Ain. Maybe you guys can open your camera for a while. Wait, I need to open my another device to screenshot this. Okay, we have Santosh Kumar. Can you open your camera? Santosh. All right. So ready, yeah? So on count to 3, I'll screenshot this. So okay. 1, 2, 3. Okay, another pose. 1, 2, 3. Okay, last one. 1, 2, 3. All right. Thank you. Thank you so much. So we will have a break for 10 minutes. Then after this, we go for Santosh Kumar for our next presenter. Thank you. You can grab your coffee, you can grab your lunch, or maybe while waiting for this break, or while waiting for our next presentation.
All right. Thank you, Ramzi. I'll be back.
All right. All right. To everyone here, especially our sixth presenter, are you here?
I'm here.
All right. So we're waiting for evaluators. So Dr. Ari and Dr. C and also Dr. Safa already in. Dr. Fatah, are you here already?
Yes, I'm here.
All right. Okay, cool. So I've start sharing first. All right. Since Santush already ready, so I start sharing his video. It's still loading.
Good day everyone, my name is Santosh Kumar and today I will be presenting my project on preparation of titania in oxide as photocatalyst in the photodegradation of organic pollutant. This project was supervised by chemist Dr. Sheila Chandran from Department of Chemistry. Titania is a well-known metal oxide photocatalyst due to its several advantages such as non-toxic, cost-effective, and has a wide application in photocatalyst, sensor, and coating. However, there are several limitations that might reduce its efficiency, which those are the problem statement for this study. First of all, several previous studies have done direct modification using metal oxide. However, it has a tendency to reduce the photocatalytic performance since the surface of titania is being fully covered. Not only that, titania has large band gap energy which is around 3.2 electron volt, which will increase the recombination rate between positive holes and electrons. Titania is only able to active under UV light range. This is also mean titania is only able to absorb only 5% of our solar radiation. Hence, in this study, titania has been encapsulated in hollow copper oxide shell, which will combine the properties of both copper oxide and titania in providing a better material properties without any direct modification on its surface, retain and even able to enhance the photocatalytic performance. The objective of this study is to synthesize titania particles encapsulated in hollow copper oxide shell to determine its physiochemical properties and then to test the photocatalytic activity of the synthesized sample in the photodegradation of organic pollutant under UV and visible light irradiations. Moving on to metallurgy. Commercially available titania undergoes carbon coating using glucose, which will synthesize carbon titania. This carbon titania undergoes copper oxide coating using different concentration of copper oxide, which is 0.5, 1.0, and 1.5 mole. At last, calcination was done in order to remove the carbon layer, leaving a wide space between copper oxide and titania. The synthesized sample was then characterized and photocatalytic activity testing using naphthalene as a model of organic pollutant was carried out. Moving on the results and discussion, TEM was used to study the morphology of the synthesized sample. From this, we can see titania is being successfully encapsulated in hollow copper oxide shell. This also means higher concentration of copper oxide result in a thicker copper oxide shell layer. The crystallinity of the synthesized sample was determined using X-ray diffraction. The peak observed was in a good agreement with the database of NFs and rutile phase of titania together with the copper oxide peaks. Based on the literature review, the mixture of two phases of titania are said to perform better in photocatalytic activity compared to single phase. For this sample, it consists of anaphase phase with a small amount of rutile phase of titania. UV-vis and IR spectroscopy was used to determine the band gap energy changes between the reference titania and also the synthesized sample, as the concentration of copper oxide increases, the reduction in the band gap energy become more evident. This might be due to a greater amount of photogenerated electron from copper oxide that migrate to the conduction band of titania instead of its surface. In the photocatalytic activity, the concentration of copper oxide, which is 1.0 mole, was observed as the optimum concentration as it performed the best in the photodegradation of naphthalene under UV light and visible light irradiation. Optimum concentration are said to be related with the optimum whole electron separation without reducing any electron in the conduction band of titania or blocking its active site. It is also proven that what sample perform better in the photocatalytic activity compared to direct modified sample, which support our claim earlier. As the conclusion, different concentration of copper oxide used in this study varies the thickness of the lateral copper oxide shell. The right amount of copper oxide, which is 1.0, give better photocatalytic activity in the photodegradation of organic pollutant. Next, it is also proven direct modification on the surface of titania cause effective light absorption, which will reduce the photocatalytic performance. Hence, titania encapsulated in hollow copper oxide shell photocatalysts display the ability to be a good visible light active photocatalyst in solving environmental related issue. With that, thank you.
All right. Thank you so much to our 6 presenters, which is Santosh. So maybe we can open Q&A session for evaluators.
All right. Thank you very much for the chairpersons. So Santos, thank you very much for the presentations. I'm actually got simple questions. I'm trying to find the entire poster to know what is the organic pollutant that you are trying to degrade, but I failed. So can you tell me what exactly is the pollutant?
I mean, I actually pasted in the poster, but then maybe in a small part.
I can't find it. Oh, you can tell me now.
Okay, yeah. The organic pollutant that I use to degrade is naphthalene.
Sorry?
Naphthalene.
Oh, it's just a naphthalene then. All right. Okay. So why you choose that naphthalene instead of you choose other PAH compound?
At first, I would like to test with benzene because during this project, it was closely related with our Sungai Kim issue. So I thought of having a chance by degrading benzene because benzene, we know that it's been one of the organic pollutant found in the water. But then since I use UV spectroscopy, spectrophotometer to test the photocatalytic performance, benzene are very hard to be detected. So therefore, I use naphthalene to test the photocatalytic performance of the synthesized sample. So one of the reasons is to be so that it's a bit easier to be detected by UV, and yeah.
Okay, so just a small comment. Naphthalene is quite volatile. So if you just leave it there, then your naphthalene is evaporative and then you will become volatile and disappear. So just wondering, sometimes if you look at your photo degradation, is it really due to your photo degradation or your naphthalene is actually disappeared by itself, So it's a kind of concern that if you choose a naphthalene which is not so stable in general. All right. Okay, thank you very much. Thanks.
Thank you, Doctor.
Hello, Santosh.
Hi, Doctor.
Right. I just have maybe a simple question. So, did you synthesize your own TiO2 by yourself, or just use it as it is?
No, I use commercially available titanium. I mean, the titanium from outside sources. So I just modify the available titanium.
Mm-hmm. So, all right, you are now currently in which semester, Santosh? Seems like you have completed all what do you call it? your target for this project, is it? Or do you
No,
have
no,
any other things?
this
Can you-
project was a part of my PSM project. So yeah, I'm currently in my semester 2 of master. So I'm doing something with us. I mean, going to synthesize the same photocatalyst, but then with a different parameters to be tested in different parameters during the photocatalytic activities, and also using other than nectarine. So like for now, I'm working on photodegradation of antibiotics residue.
All right. I think that's it from me. Thank you very much, Santosh.
Hi, Santosh. Santosh, is it?
Yeah,
The way I
Santosh.
pronounce your names, I hope it's correct. If
Yeah.
okay. Just a simple questions. Why the photolytic activity is important in photodegradation?
Because in photocatalytic activity, we use two different type of light source, which is UV and visible light. So if we look at our solar radiation, from base of my literature review, only 5% of our solar radiation consists of UV light. This was what based on my literature review. So other part is it consists of, if you compare the percentage of UV and also visible light is much more than the UV. So visible light is in a simple way, it can be our own light source, in our room light source. So why not we utilize the higher percentage of light that available in our solar radiation for the photodegradation of organic pollutants. So that's why titania itself is already active in UV but not invisible. So by this study, what I'm trying to say is like, why not we try titania under visible light as well? So this light will actually give energy to the titania so that it reaches the minimum it gives the energy to the electron in the titania so that the titania will be the electron will be moved from conduction band to valence band. So that's the importance of our light source in our photocatalytic activity.
So between visible lights and UV light, so visible light will possess higher photocatalytic activity.
Actually, I did not compare between UV and visible light. I only did what is the best optimum concentration under UV, and will this synthesized sample able to active under visible light. But then from a rough idea, what I can say is this photocatalyst can be active in visible light better than UV due to the modification. Because due to the modification, we are able to reduce the band gap energy. So the band gap that we got is actually the in between of range of visible light and band gap energy.
Okay, thanks.
Okay, thank you, Doctor.
Is there any other
Ramzi,
question?
no question from me because my question is similar to the Dr. Si Heng.
All right. So yes, that's it for the Q&A session for Santosh. So thanks a lot for your presentation. So now we have 5 minutes for the evaluators to fill in the evaluation form. So our next presenter is Atia Abdul Hadi. So are you here?
Yes, can you hear my voice?
I hope you are ready for your presentation after this. All right. Seems like all the evaluators already done with the evaluation form. So let me stop sharing first. So now we go to our 7 presenter. So let me start sharing.
Assalamualaikum and greetings to everyone. My name is Atia binti Abdul Hadi. I'm going to present my poster pitching for this competition entitled Comparative Study of Photosynthesized Silver Nanoparticles from Local Ulam Leaves Extract. So from this title, I'm going to explain where I compare a few types of plants which I use as the raw materials, and I subjected the ulam leaves to synthesize silver nanoparticles and compare the formation of the nanoparticles itself. So basically, the role of plant phytochemicals in green synthesis has drawn undeniable attention for synthesizing stable and eco-friendly nanoparticles. So the use of plant extract for silver nanoparticle synthesis is shown to be advantageous compared to other conventional methods such as chemical, physical, due to their low cost, non-hazardous, and being environmentally tolerable. So, photosynthesize means we synthesize the silver nanoparticles from plants. Why plants? Because they are abundantly available. They are local edible plants in Malaysia. And second, I use aqueous extract. This is to avoid toxic chemicals and solvents. And why to synthesize silver nanoparticles? Because it is well known for its antibacterial capacities. So this project explores the potential of using Malaysian local leaf extract, so such as 4 types. Persicaria odorata, which is the kesum leaf, Oenantha javanica, which is the cellum leaf, Serapis androgenes, which is the cekomanis leaf, and fourth is the Ethyliniella elator, which is the bunga kantan leaf. So why we use plant leaf extract? And what is the problem? So basically the problem is it is difficult to control the nucleation and growth of silver nanoparticles when we use plant extract, because there are abundant of phytochemicals in the plant extract itself. Comparable to chemical synthesis, it is quite difficult to control. Usually we produce nanoparticles of size bigger than 20 nanometers. So we aim to target the yield of small size silver nanoparticles for better antibacterial properties. So we hypothesize that herbal plants with high antioxidant content has high reducing power. So metal chelation is widely considered to reflect the antioxidant activity of the phytochemicals in this category, the flavonoids. The higher the reducing capacity, the higher tendency to form silver nanoparticles. So the objective of this study is to investigate the antioxidant properties of different leaf extract based on the antioxidant assays, and to study the correlation between the antioxidant capacity and the formation of the AGNPs. So the nanoparticle formation is monitored using the UVs. Firstly, the plant extract of the 4 ulams are subjected to FRAC assays and the DPPH assays. Then we monitor the AGNP formation by using the UVVs, and we characterize the biosynthesized silver nanoparticles using FTIR. So basically the results is here. We can see the summary of the results of different leaf extract. So basically the highest reducing capacity goes to the Persicaria odorata, which is the kesum, with faster formation of silver nanoparticles within 24 hours, and with the highest FRAC value and the highest DPPH values. So the dominant compound which contribute to its highest reducing capacity is the quercetin and miracetin. So this is from a literature review. So basically, Pussycardiality is the highest. Second is the Daunkantan leaf. Third is the Cecomanis leaf, and fourth is the Ceylon leaf. So what is the significance of this study? There is a positive correlation between the antioxidant capacity of the leaf extract and its reducing power against the formation of nanoparticles. So basically, the formation of nanoparticles is established by looking at the antioxidant capacity of the flavonoid. So this can be used as an innovative antioxidant detection assay for samples rich in phenolic compounds. So that is all from me. Thank you very much for giving me this opportunity. That's all from me. Thank you.
All right, thank you, Atia Abdul Hadi, our seventh presenter for the presentation. So now we open for the Q&A section.
Okay, Assalamualaikum Atia.
Assalamualaikum.
Okay, I think this time I will go first. My question is, how did you determine or identify which plant you want to study?
Okay, so firstly, the selection, this project is my first stage of my PhD, so I need to choose which plant I need to use.
Okay.
So I've gone through a few review papers about local ulams in Malaysia, and I screen all four by looking at the highest value for the TPC, TFC, ferret reducing prep, and DPPH. So basically, I just shortlist the top 10, and I see which ulam and the availability in the market, so that we can use it as raw materials. That's all.
So the top four that you listed here is the ones that easily available in the market.
Yes.
Is it with the high antioxidant capacity?
Yes.
Okay. Okay, I think that's all.
Okay, Atia, Okay, so basically, the questions related to the Dr. Abdul Fattah. Okay, so you mentioned that you have listed top 10, right? Yeah. Dengar
Can
tak?
you a bit louder?
Oh, ya ke? Hujan
Tak
pun
dengar.
ni. Okay, sekejap Okay, saya rapat ke sikit. Okay, so you have listed top 10 ulam. Okay, so then you mentioned that four top 4 tu is easy to get
Yes.
How about okay, kalau yang katakanlah the listed on the fifth ulam tu, is it the properties will be the same? I mean the
properties.
You choose 4 kan?
Yes.
So dia punya result will be the same tak? With the top 4 tu. But you mentioned
top 4 tu ke?
you listed top 10. So you mentioned you choose 4 because of the easy to get.
Yes.
Tu kan? Okay, kalau yang kelima tu senang dapat, dia punya agak-agak dia punya result tu sama tak dengan top 10 top 4 yang you analyse tu?
Tak sama. Because firstly we shortlist by looking at the antioxidant capacity. So the even by just using these 4, the result is quite different. The size of the nanoparticles that we manage to synthesize is different. So for example, actually the graph is not that clear. So for example, that the kesum leaf, we managed to get less than 20 nanoliters of silver nanoparticles. For the cecomanis, we managed to get around 60 to 70 nanoliters size of silver nanoparticles. So actually, it depends on the antioxidant properties of the plant.
Okay. So kiranya even the 4 tu pun your result pun gap dia sangat besar
Betul.
Okay. Okay. For now itu je soalan saya for me. Kalau ada apa saya tanya balik ya.
Sampai dia question.
Okay, let me go first. Beginning over here, I can capture my voice. Catch point at the back. Boleh dengar tak Adia?
Tersekat-sekat.
Alright. I try to be that I can. And I just nak comment sikit. Maybe you can justify a little bit. Your second objective is basically the correlation between NPS and formation of NPS, against nanoparticle lah, before NPS. I think you need to be a little bit more specific lah. The relation, what activity of anti-NPS formation? Are you comparing it with the concentration of the nanoparticle, or are you comparing it with the monodisperity or size or morphology of the single nanoparticle? What is it about? Yeah, maybe you can comment a little bit.
So for the second adjective, I can just relate to the UV SPR band, in the UV SPR band. So I can say that the Secura odorata, we get peak at the top left. So basically when we have the left at the left wavelength, so we can say that it has a blue shape. So when blue shape, we can note that it is of small size and possible of monodispersity. So basically we can just compare from the UV based SPR band.
Alright, so if that is what you are seeking for, you might need some other calculation. Maybe you might not, you cannot rely basically just on the location of SPR peaks. My suggestion. Thank you.
Okay, thank you, Doctor.
Okay. Thank you very much for your presentation, and I don't have any further question for you. Thank you.
Thank you, Doctor.
Okay, if Dr. Si Hong don't have any questions, I have an additional questions for you.
Okay.
You are using the okay, you are using the kesum, right? Perscaria orodata. Okay, do you know there is a variety of kesums such as Perscaria minor, right? Quite abundance of species of kesum. So how do you identify the correct one?
Okay. I know there are a variety types of kesum. For example, polygonal minus or polygonal minor is the wild type, which is we can find in the forest. So basically, I just take the Perscaria odorata and I've sent it to the frame, the forest, the frame identification for species. So I just take from that single place, I take it in bulk amount, I send for species identification, and then I just proceed for the whole experiment from the bulk raw material.
Okay, that's all. Thank you.
I think that's it for our presenter. Okay, thank you so much, Ati Abdul Hadi. So now the time for the evaluation form has started. So I already sent the evaluation form in the WhatsApp group. So for our eighth presenter, which is let me check in. Okay, so our eighth presenter is Wan Faiza. So are you here?
Yes, Ramzi.
All right.
Yes.
Cool.
Is
Okay,
it?
so you are ready?
Okay.
Okay, all right. I hope one Faiza is ready. So I'll stop sharing. Okay. So I'll start sharing your video, yeah.
Assalamualaikum warahmatullahi wabarakatuh and a very good day to all viewers. I'm Wan Faiza as a presenter for the virtual scientific poster competition which is entitled Unsteady Gas and Fluid Flow Through a Vertical Cylinder. Let me briefly introduce about the problem. What is a gas and fluid? Gas and fluid is a non-Newtonian fluid which is its behavior does not obey Newton's laws of viscosity. It is also known as a shear thinning fluid with a yield stress. For examples of the gas and fluids are blood, honey, jelly, and others. Most of the researchers study the gas and fluid problem in a vertical channel, which is in a Cartesian coordinate. But recently, it has been extended into a cylindrical coordinate since it is more close to the real-life application. Most of the researchers solve the problem numerically with the slip velocity effect at the boundary. However, only a few researchers are studying the problem theoretically. What is a slip velocity? Slip velocity is a finite velocity of a fluid at a boundary, or other words, the velocity exists between the two different medium. In a real life, slip velocity is existed. For example, like a real life application is oil and gas drilling process, blood flow in arteries, and others. Laplace transform and a finite Hankel transform will be used to obtain the analytical solution. The aim of the research is to investigate the unsteady gas and fluid flow in a vertical cylinder with the slip velocity effect at the boundary. There are three objectives of this problem. First is to transform the dimensional governing equation into the dimensionless equation. Second is to obtain analytical solution for the velocity profiles. Third is to analyze the obtained analytical solutions graphically by using the Maple software. Next is the significance of the problem. First is to introduce new knowledge of theoretically study that can be a great reference to researchers, engineering applications, and educations. Second is to enhance the knowledge of the fluid velocity analysis of a gas and fluid through a vertical cylinder. And the last one is to obtain the analytical results can be used to check the accuracy of the results in the numerical study. Next is the research flowchart. Propose the problem and then obtain the governing equation from the published paper, as we can see in the equation first, and then do the non-dimensionalization process in the equation 2, and apply the Laplace and Hankel transform to transform the equation, as we can see in equation 3, and reduce the linear ODE. After that, apply the inverse Laplace and Hankel transform in order to obtain the analytical solutions of the problem, as we can see in the equation 4, and do a validation, and lastly is a conclusion. Okay, as we can see, there are two results for this problem. First, in figure 2, which is show the velocity profiles for different gas and parameters. From observation, we can see velocity profile increases as the gas and parameters increases. It is due to the fact that once gas and parameter increase, it will cause yield stress to fall and a boundary layer thickness will decrease, which is result in enhancements of the fluid velocity. Second result is in figure 3, which is show the differences between the velocity profiles of gas and fluid and a Newtonian fluid. As we know, when the gas and parameter is approaching the infinity, it will behave like a Newtonian fluid. Fluid velocity of Newtonian fluid is a uniform from the boundary, which is at the 1, to the center of the cylinder, which is at the 0. Meanwhile, for the gas and fluid, it is decreases as approaching to the cylinder, center of the cylinder. Okay, it is due to the why? It is due to the boundary layer thickness gas and fluid larger than the Newtonian fluid due to its plasticity behavior. As a conclusion, the solutions are satisfied with the initial and boundary conditions. Second, the velocity profile increase when the gas and parameter is increased. And the last one is the fluid velocity for the Newtonian fluid is uniform from the boundary to the center of the cylinder, while Cassian fluid is decreased while approaching to the center of the cylinder. That's all for me. Thank you for the listening.
Okay, thanks a lot to Wan Faiza, our eighth presenter. Okay, now we open for Q&A session.
Okay, thanks, Wan Faiza, for your presentations. I would like you to clarify a term for me. What is the Cassian fluid and Cassian parameters? Can you differentiate it for me? Is it the same thing?
Okay. Cassian fluid is a fluid type of non-Newtonian fluid. Cassian parameter is the parameter for the it exists in the Cassian fluid equation.
I cannot hear you clearly.
Is it, you can hear me?
Yeah. Can you louder? Maybe
Okay.
because it's raining.
Okay, sorry. Okay, Cassian fluid is the fluid itself, which is we call one of the non-Newtonian fluid. For the Cassian parameter is the parameter exists in the equation for the Cassian fluid.
Mm-hmm. So
As we can
Cassian,
see, we can see the my poster. There is a beta. Beta. This one we call the. I use beta as a Cassian parameters to solve the equation. It show the which is it show the behavior. Cassian parameters will show the behavior of the Cassian fluid.
okay. Understand.
Okay. Is it clear?
Okay, yes, thanks.
All right. Dr. C, can I go first? I think so.
Yes, no problem.
Okay.
Go first. Yes.
Thank you. So thank you very much, Wan Faiza. I think your presentation video was very clear. So I have a few questions for you, maybe to clarify a little bit. The first one is basically, how do you justify that your velocity profile for both Cassian and Newtonian fluid is basically close or representing the real practical application lah? How do you get, maybe you do something to get the idea whether your simulation is closely related to what is actually going on? All right, that is the first thing. You can answer based on your understanding. The second question is maybe conceptual. If someone were about to do this experiment in the moon, would you have the same expected results as based on your calculation? I don't know. Maybe you can emphasize to me or explain to me a little bit. Is it clear? Wan Faiza?
Okay. Yes. Yeah.
Thank you.
I
Please
try to
carry on.
answer the first question. How to verify? Yeah, Dr. Safai. This one I based on previous paper. I validate the my data. For example, like I refer to the before this I refer to the other fluid, and also I compare to the other fluid, like for example like a Jeffrey fluid and also Cassian fluid, but in other different conditions. So from that one, I verified my results. Is it correct or no? That's the how I verified my results. And the second is I verified my results based on the initial and boundary conditions. Is it satisfied or no? Because based on inside my poster, we can see the second equation. There is an initial and boundary condition, which is based on the graph, it is satisfied initial and boundary conditions. So that's why validate my results is correct. Okay, for the second questions, this one for Adam one, sorry, that's one I'm not really sure about this because, but from the based on my understanding, I'm not sure is it correct or not because I'm not yet proved that equation. I think I'm not sure because the moon different gravity from the earth. So, but in my equation, there is not related with the gravity, not involved with the gravity force. So I'm not sure is it applicable or not. But for me, it is applicable. Same like
at the moon because no gravity force applicable used in the equation.
So you will think you will get the same simulation result lah, regardless of the where about you carry out the real experiment.
We should try first.
All right, okay, thank you.
but because there is no experiment yet done for my question, this one.
No
But
problem. That's
based
why I
on
said it was a
concept only.
conceptual.
Conceptual,
All right,
no gravity force involved in my equation. Okay.
Okay.
Thank you.
Thank you very much. Thanks for the presentation. So I'm trying to read through and trying to figure out, and just wondering, is this a problem-based solving research, or this is more very, very fundamental theory research?
Sorry, sorry, doctor. Prof, sorry. One more.
Is this actually a more like a problem solving research, or this is more like a fundamental theory investigation research?
Problem solving.
So you, in your proposal, you didn't mention what is the problem that you want to solve. So can you just simply mention what's the main problems that you would like to tackle?
The main problem I want to solve is the Carson fluid with the velocity slip in the cylinder. Velocity Carson fluid, unsteady Carson fluid flow inside the cylinder with the velocity slip at the boundary of the cylinder.
Okay, good. Something interesting to me, and yeah. Okay, thank you very much. Thanks. Yeah.
Is there any other question from the evaluators? No. So if there's no questions, so I think that's it for our eight presenter. So thank you so much, Wan Faiza. So now
Thank you.
we have 5 minutes for the evaluators to fill in the evaluation form for you. So we just wait. So for your information, we actually have 10 presenters, but our next presenter, which is our 9th presenter, Ain Ajira Ramli, is not here, is absent because of the sick leave. So she couldn't be here. So there's a lot of chances of winning for you guys because we have lost one participant today. So we straight forward to Navin Eugene. So Navin Eugene is our 10th presenter. So are you here, Navin?
Yes, I'm here. Thank you very much.
Right, cool. So we wait for the evaluation form first. Then I hope you are ready for your part.
Yes, sir.
Okay, right. All the evaluators have already finished with the evaluation. So now we move on to our last presenter of the day, which is our 10th presenter called Nervin Eugene Lewis. So let me share your video first.
Greetings everyone, my name is Naveen and this video submission is with regard to the virtual scientific post and pitch competition. First, I'd like to thank my supervisors Dr. Sazwani and Dr. Nuriza for their immense support. Alright, so head and neck squamous cell carcinoma accounted for more than 800,000 new cases and 430,000 deaths in 2019. As you can see, it's highly heterogeneous where it can arise in the oral cavity and lip area as well as the hypopharyngeal area. Moreover, the fact that half of patients do not survive stresses the need to actually look for better treatment strategies. Over the years, scientists have actually identified that the epidermal growth factor receptor is overexpressed in 80 to 90% cases of head and neck squamous cell carcinoma cases and correlates with poor prognosis and treatment outcomes. So why is that, and what is the epidermal growth factor receptor? So basically, it's a transmembrane protein that is a receptor for members of the epidermal growth factor family of extracellular protein ligands. So as you can see, the epidermal growth factor actually binds to the epidermal growth factor receptor and undergoes dimerization that actually leads to a downstream signaling cascade that leads to cell proliferation and survival. And anti-cancer agents such as monoclonal antibodies like cetuximab actually bind to the epidermal growth factor receptor and actually prevents the ligand from binding to it and prevents dimerization and prevents all the downstream signaling involving like cell proliferation leading to apoptosis of cancer cells. As mentioned earlier, monoclonal antibodies have been very promising for treatment. However, somatic mutations tend to actually alter the structural conformation of the epidermal growth factor receptor, and this actually leads to reduced affinity between the monoclonal antibody and said receptor. A study by Tabazinasad actually employed molecular dynamic simulation, and he actually evaluated the reduced affinity of cetuximab and other monoclonal antibodies towards the epidermal growth factor receptor. The next class of therapeutics are actually called tyrosine kinase inhibitors, and they're actually small molecules that block the intracellular kinase domain of the transmembrane receptor, preventing its autophosphorylation and subsequent activation. Moreover, this actually leads to an inactivation of downstream signaling transduction pathways such as the AKT, STAT, and MAP kinase pathways. However, the major disadvantages of using tyrosine kinase inhibitors involve point mutations because they actually lead to resistance against tyrosine kinase inhibitor therapy and within the kinase domain, which actually decreases the affinity of the tyrosine kinase inhibitor to the binding domain. Right, so the first objective of the study would be to identify compounds that bind energetically favorable to the C terminal of the epidermal growth factor receptor. This can actually be done by using AutoGrow4, which is an open source program for semi-automated computer-aided drug discovery. So we can actually identify which type of ligands can actually be bound to the C terminal. The C terminal is actually located at the intracellular domain of the epidermal growth factor receptor. So unlike monoclonal antibodies, these compounds actually have to bind to the intracellular domain. Right, so what's the reason of actually choosing the C terminal of the growth factor receptor? So basically, the C terminal lobe of one molecule activator packs against the N terminal lobe of the other receiver, thereby stabilizing the active conformation of the kinase domain, leading to dimerization and cell proliferation. So if we were actually to identify a compound that is able to induce a steric clash between the C and N terminal, that would indirectly affect dimerization and actually inactivate the epidermal growth factor receptor downstream signaling. The second objective of the study would actually be to evaluate the behavior between the C terminal of the growth factor receptor and the identified compound using molecular dynamic simulation. So in doing so, we can actually identify how the identified compound behaves with the C terminal of the growth factor receptor. We can look into the hydrogen bonds and the free binding energy between the two of them. And we can also perform a further validation by simulating the identified compound along with the C and N terminal of the growth factor receptor to check whether there was any steric clashes induced as a result of docking the compound. So third and final objective of our study would be actually to translate our in silico findings into in vitro experimentation using the ORL 136 cell lines, which actually have high expression of the epidermal growth factor receptor. So if they were able to hinder dimerization, we would actually assume to have low levels of the epidermal growth factor receptor, and that could actually potentially treat patients with head and neck squamous cell carcinoma. So since chemotherapy, monoclonal antibodies, and tyrosine kinase inhibitors have been the main strategy so far, but due to point mutations on the BCR-ABL gene or the epidermal growth factor receptor has actually conferred resistance against such treatment. So we actually hope that since the C-terminal has a very low secondary structure, its conformation will not get severely distorted due to mutations. And moreover, it has the potential to actually reduce mutation-induced structural alterations, leading to prevention in treatment resistance. So thank you very much for listening.
Okay, all right. That will be our last video, our last pre-recorded video for today. So thanks a lot to Naveen, Eugene for our 10th presenter. So now we open for a Q&A session.
Thank you, sir.
Okay, thanks Naveen for the presentations. I would like to know, is it the whole study is carried out in dry lab?
No, sir. Actually, this is actually totally different from my master's. My master's is something totally different. So me and my supervisor are reading a few papers and we had this idea. So the initial screening process would actually be bioinformatics to actually identify a compound that can induce a steric clash between the N and C terminal. So we, instead of like wasting resources and just doing cell culture, we have to actually be thorough with our theories first. So the initial first objectives would actually be purely computational to check if the compound actually affected dimerization. Then we would only carry out in the wet lab and actually validate our findings to actually identify the cytotoxic effects of said compound, and actually it is really able to reduce the epidermal growth factor receptor levels.
So it's divided into two parts, one
Yes,
dry lab and then another is the wet labs. The
Yes,
wet labs will be involved the screening.
Yes, sir. Yes, sir.
So how do you do the validation?
So initially we would check, we would perform pharmacophore modeling to check if any compounds can actually bind to the C terminal, because it has a very low secondary structure. But that's actually advantageous because mutations don't affect the C terminal tail much. So patients cannot actually acquire resistance to that type of treatment. But the second objective would actually be to simulate our identified compound and the C terminal to see how its affinity changes throughout the simulation, and that can actually be our stepping stone to actually validate our compound using cell lines. So that would, each step has a validation to it. So the molecular dynamics simulation step would actually be done to perform a simulation with the identified compound and the C terminal. Then the second validation step for that would be to simulate the epidermal growth factor receptor in its dimeric form and to simulate it and to check whether dimerization is affected. And that means our compound is actually working in inducing a steric clash between the N and C terminal of the receptor. So then we could actually validate our other findings using real in silico data and to actually check the robustness of our bioinformatics study. Yeah.
So the validation is still on the bioinformatics?
No, the initial screening of the compound will be bioinformatics, and then after we're actually confident with that, we would actually continue and into in vitro studies. The validation, final validation will be using cell lines, sir.
Okay, what type of cell line that you use?
Okay, so the Cancer Research of Malaysia have actually developed a cell line that is expressing high epidermal growth factor receptor. So it's actually patented as the ORL 136 series. So it's actually from our country. It's Malaysian, made from the Cancer Research of Malaysia.
Okay, that's all.
Thank you, sir.
Can I continue?
Yes, sir.
All right. So thank you very much, Naveen. Maybe I leave the technical part to the rest of the examiners, right? I don't want to go into that. All right. So maybe what I can comment is basically your video is, for me, the face of your narrating your poster is a bit too speedy for me. You know, it's hard for someone like me from other than bio or chemistry to basically to catch up with what you are trying to present? I know something is you have been doing there and you want to present it to us. Maybe you can lower down the speed. That's one thing. And the second thing, based on your poster, where I don't know where is it going. I think I mean it has no conclusion, or maybe now you can give us some brief on what you would like to conclude, as it is not clearly written in your poster lah.
Yes, sir. Actually, this is totally an idea, sir. From literature review, this is totally an idea. So we have not done any experimentation.
Oh, all right. So there is nothing to conclude at this stage.
Yeah,
right?
nothing.
You can say that.
It's just an idea from reading. Me and my supervisor, we were just reading a couple of papers and we thought of an idea. So yeah.
All right. Cool. I think that's it for me. Thank you.
Thank you, sir.
Leave it to the other.
Hi. So thank you very much for the presentations.
Thank you, sir.
So actually your idea is actually to compare the structural stability and then using molecular dynamic simulations.
Yes,
so how you actually measure the structural stability?
Yes, sir.
What's the experiment that you're going to do?
Yes, sir. So currently, my master's is actually looking into molecular dynamics simulation studies with G6PD protein. So I took the molecular dynamics simulation part and tried to apply to this idea. So we can actually identify the structural stability by different parameters from simulation studies. So we have different parameters like the root mean square deviation. We have parameters like the radius of gyration. We have free binding energy. So we can actually identify the stability based on different factors. For example, if we want to measure the stability between the ligand and the C-terminal complex, we can look into the number of hydrogen bonds made, the free binding energy, whether it's negative, or we can also look into the solvent accessibility surface area. So all this is purely computational, and also it gives insights on how the protein might behave in our body. Although computational studies, they have their drawbacks because they can't exactly mimic how proteins and ligands behave in the body, but it does give an idea, a rough idea of how the interactions might behave. So based on those findings, we can actually try to validate them using cell lines.
Okay, good. So I'm looking forward to see more of your result in the future. But it's a very interesting idea.
Thanks a lot. Thank you so much, sir.
Thanks.
Okay, Nervin, I think a very simple one before we end our session today. So basically, this idea from discussion between you and supervisors, right? So what's your future plan? Is it your plan? Maybe because of the idea. So you have your next plan, what you need to do. So is it you want to have a collaborations with clinical or something? And then one more thing, is it you have presented this problem to other platform?
Not exactly. So actually, when I first saw this post and pitch competition, it said like if you have any novel ideas and stuff. So it got me and my supervisor discussing, and then we thought, why not? We found a few papers that stress the importance of molecular dynamic simulation, and then I've read a few papers as well. And in Southeast Asia, in Malaysia as well, the incidence of head and neck squamous cell carcinoma is really high. So if we can actually address the real problems that we're facing now, and one of this is really common, and actually give a kind of solution to it, and could be beneficial if we could actually collaborate with the Cancer Research Malaysia as well, because they actually established cell lines, which is really fantastic, I think, for our country to do so. So if we could actually collaborate and actually find a cure and actually help patients who are actually conferring resistance to different types of treatment, this could actually benefit a lot of people and save many lives. So that's the main idea. I mean, if it's out there, I think it can benefit people, and I think that's the main reason why we all do science. So yeah.
Okay, thank you so much. So I hope your plan will going well, and then good luck for your research.
Thank you so much. Okay? Thank you.
That's all for me, Ramzi.
Thank you, sir.
Is there any other questions from the evaluators? So if there's no other questions, so I think that's it for today. So thank you again to our last presenter, Navi, Eugene.
Your time. Thank you so much.
Okay, for your information, the marks is already filled in the evaluation forms, but we are not going to announce it today. So the winners of these competitions will be announced during the closing ceremony. So stay tuned during that date on this 21st. I believe it's on Sunday. So if you are willing to know whether you are winning this competition or not, so you are welcome to join the closing ceremony after this. So I think that's it for today. So I would like to take the opportunity to express my highest gratitude to all the evaluators for being appointed as the sole evaluator for today's virtual scientific poster and pitch competition. And I believe it's a wrap. And I would like to take this opportunity on behalf of Faculty of Science as well as BJSSFS to thank every one of you for joining this program. And I believe that you have obtained great knowledge and we have exchanged quite numbers of knowledge from different departments, 4 departments of Faculty of Science. And I really hope to see you guys again soon in the future. So I think that's all from me. Thank you so much.
Thank you. Take care.
Right. Thank you very
everyone.
much, Ramzi, and all the participants as well as the panel, the list of panel. Thank you very much for your time.
All right.
Thank you very much.
Right.
Thanks a lot. Okay, see you around.
Thank you,
All
Dr.
right, thank you.
And Dr.
Dr. Fatah, Dr. Si Hong Heng, Dr. Kushairi.
All right.
See you guys.
See you guys again.
Bye bye.